Right, the fourth and final nucleophilic addition elimination is with an amine. Probably the trickiest one, probably because we're not that used to amines yet. So this is an organic molecule with an NH2 group. So similar to the ammonia, our nitrogen will be having the lone pair. First example with ethanoyl chloride and the simplest amine, which is methylamine. So that's just CH3NH2. So let's look through the mechanism for this one. So there's ethanoyl chloride. Let's draw in our methylamine again with the nitrogen as the focus. So it's going to be bonded to two hydrogens as well as the CH3. Let's pop those on. And don't forget we need the lone pair. Pause the video, have a go. So curly arrow 1, curly arrow 2. What's that going to make? So we're getting used to these now. That's all the same. Broken the double bond. Nitrogen bonded to the carbon, still bonded to the methyl and the two hydrogens. Let's have a look. There's the charges missing. Negative oxygen, positive nitrogen, 3 curly arrows, bish, bash, and bosh. Okay, what's that going to make then? CH3 bonded to the carbon. We've reformed the double bond oxygen, which now is bonded to the nitrogen. That nitrogen has just lost one of the hydrogens, but one still remains, as does the CH3. So this is looking a little bit unusual. We've not seen these before. Yep, there's the HCl. So there's a little bit more detail on this molecule. So with ammonia we saw that we would make an amide. So that's what we'd recognise as an amide group, although in addition to just the nitrogen with two hydrogens, this now has a methyl group attached to the nitrogen. So we'd refer to this as an N-substituted amide. On the left hand side we've still just got the two carbons. So there's a methyl attached to the nitrogen, in addition to what we'd regard as ethanamide. So let's put all this together. We have to say that the methyl is attached to a nitrogen, which in the name we will do by saying that that is an N-methyl. So that tells us that the methyl is on the nitrogen, and then simply ethanamide after that. So this compound is N-methyl ethanamide. The balanced equation in colour, just showing you what's gone where. So there's our amide, so NHCH3 in addition to the HCl. Let's have a go at another one then. So propanoyl chloride and ethylamine. Pause the video, have a go. Here's our propanoyl chloride. So 3 carbons in the acyl chloride, and here comes the ethyl amine. So that's an NH2 attached to an ethyl group, so I'm just going to show that as C2H5. Lone pair on the nitrogen. Here come the curly arrows. So this is the 4th one we've seen. We can see it's just same mechanism time after time. So just the characters that are changing. Perhaps looking a little bit more complicated now. Maybe that we've introduced nitrogens and amines. 2 charges, oxygen's negative, nitrogen's positive. 3 more curly arrows, exactly the same as before. Reform the double bond, boot out the chlorine, and the nitrogen wants to pick its electron back. Either of those, let's go for that one. Okay. What's that going to make? Now we've got the nitrogen bonded to one of the hydrogens as well as the ethyl. See if you can name this. So I've now got an ethyl group attached to the nitrogen, and on the left hand side I've got 3 carbons in my amide. So ethyl, so it's N-ethyl, and then 3 carbons makes it propanamide. So N-ethyl propanamide. Well done if you got that.